Okay, let's take a look at your homework, your practice questions on page 692. Number 1 says, what is the potential difference of a battery if it does 7.5 times 10 to the negative 2 joules of work, so that's W, 7.5 times 10 to the negative 2 joules of work, when it moves 3.75 times 10 to the negative 3 coulombs of charge, so that's Q, 3.75 times 10 to the negative 3 coulombs. And you're looking for what is the potential difference. So V is equal to W over Q. So 7.5 to the negative 2 joules over 3.75 times 10 to the negative 3 coulombs. And you should get V to equal 20 joules per coulomb or volts. Number 2. A 9-volt battery, so that's your V, causes a charge, that's your Q, of 4.2 times 10 to the negative 2 coulombs to move through a circuit. Calculate the work done. So this time you have to rearrange for W. W equals QV. So 4.2 to the negative 2 coulombs times 9 volts. You should get a W of 0.378 coulombs times volts gives you joules, because a volt is a joule per coulomb. Number 3, a 12-volt battery, so V is equal to 12, does 0.75 joules of work. That's W. If it moves a charge through a circuit, calculate the amount of charge. V equals W over Q. Rearrange for Q. Q equals W over V. So 0.75 joules over 12 volts should give you a Q of 0.0625 coulombs. First page is done. So then flip over to page 696. Number 4 says a battery sends 2.25 amps, so that's I, 2.25 amps through a circuit for 1.5 minutes, that's delta T. And of course you have to change that to seconds, should be 90 seconds. If a total of 8.1 times 10 to the 2 joules of work is done, so that's W, and it's what? 8.1 times 10, so 810 joules. What is the potential difference? What's V? So 2 steps here. First step, find your Q. I equals Q over delta T. So Q equals I times delta T. So 2.25 amps times 90 seconds should give you a Q of 202.5 coulombs. Once you have this, then you can do V equals W over Q. So 810 joules divided by 202.5 coulombs, that should give you a voltage of 4 volts. Number 4 is done. Number 5 says, how long would it take? So you're looking for time. How long would it take a 17-volt battery, so V is 17, sending 5 amps of current, so I is 5 amps, to a circuit to do 680 joules of work? Okay, so you're looking for time, but first you're going to have to find Q. So you have V and W, so V equals W over Q. So Q equals W over V. So 680 joules over 17 volts should give you a Q of 40 coulombs. Then you go to I equals Q over delta T. So delta T equals Q over, this is an I really. So Q is 40 coulombs, I is 5 amps, and so delta T should be 8 seconds. Number 6, how much work is done? So you're looking for W. How much work is done by a 25-volt battery? So V is 25 volts. When it drives 4.7 amps, so that's your current, I, through a circuit for 36 seconds. Delta T is 36 seconds. So first step, find your Q. My sheet keeps moving. So you have I in delta T, so I equals Q over delta T. So Q equals I times delta T. So 4.7 amps times 36 seconds. That should give you an I of 169.2. Sorry, not an I. That should give you a Q of 169.2 coulombs. Once you have that, then go to V equals W over Q. So W equals Q times V. So 169.2 coulombs times 25 volts, and you should get work done to be 4,230 joules. Okay, number 7 says 160 volt battery, so V is 160 volts, does 9.6 times 10 to the 5 joules of work, so W, 9.6 times 10 to the 5 joules, in 2 minutes. Delta T, 2 minutes, which is, of course, 120 seconds. What's the current? First step, find your Q. So, V equals W over Q. So Q equals W over V. So 9.6 times 10 to the 5th joules divided by 160 volts should give you a Q of 6,000 coulombs. Then do I equals Q over delta T. So 6,000 coulombs divided by 120 seconds, you should get a current of 50 amps. Okay, so hopefully these are pretty straightforward for you. That was number 7. Number 8 says a light draws a current of 0.48 amps. So that's your I. How long must it be left on? So you're looking for delta T for a charge of 36 coulombs to pass through it. So Q is 36 coulombs, only one step in this one. I equals Q over delta T. So delta T is equal to Q over I. 36 coulombs over 0.48 of an amp. You should get a delta T of 75 seconds. They should have led with that one. Number 9. An electric circuit draws 20 amps. So I, 20 amps. If the electric potential drop over the circuit is 120 volts, so V is 120 volts, calculate the total charge, looking for Q, that's going to pass in 1 hour. Time, 1 hour, or 3,600 seconds. They gave you that V to screw you up. You don't need it. I equals Q over delta T. So Q equals I times delta T. 20 amps times 3,600 seconds. Q should be equal to 7.2 times 10 to the 4th coulombs, or 7.2 with 3 zeros. So, number 10, cell phone batteries recharge 0.25 of an hour. Receiving the Q is 2.5 times 10 to the third coulombs, and it wants to know what's the current. 0.25 of an hour is going to be 900 seconds. They should have led with this one. I equals Q over delta T. So 2.5 times 10 to the third coulombs divided by 900 seconds. I is equal to 2.78 amps. And we are done. Okay, so hopefully those ones were pretty straightforward for you.